In this video, we're looking at curve sketching and the key features of graphs. So on your screen, we're going to go through a couple of summaries of the strategies we use for sketching a curve. So one of the most important ones is using the stationary points to determine their nature. So what I mean by that is, we already know that a stationary point occurs when the first derivative equals 0, and we know that it's a minimum turning point if the second derivative is greater than 0. So we can use that to help us identify minimum turning points on a curve. Now, if you can't get the second derivative because the function's too difficult, remember you can always use the first derivative. So if the gradient goes from negative to positive, that indicates a minimum turning point. Now, in terms of maximum, the same thing, the first derivative is at 0, and if the second derivative is less than 0, you know you have a maximum turning point. Now again, if it's too difficult to find the second derivative, you can use the first derivative, and if you go from a positive to a negative on both sides, so if the left hand side's a positive, and then you go to the right hand side and it's a negative, this indicates a maximum turning point. Now another step is finding the points of inflection and check the concavity. Now remember, points of inflection are found when the second derivative is 0 and the first derivative is 0. Another important thing to note is finding x-intercepts and y-intercepts. So x-intercepts occur when y is 0 and y-intercepts occur when x is 0. You may also need to find the domain and range for the function. Now remember, the domain is all possible x values and the range is all possible y values. It's important to note that some functions will have asymptotes or other discontinuities, so you need to find them. Now, an asymptote, remember, is a line that a curve approaches but never actually reaches. So it should look something, if you've got an axis here and you've got a dotted line coming down here, it's something where the curve will eventually get infinitely close but never actually reach. Now, it's also important to note that you can use symmetry as well, and remember, when I talk about this, is you need to find if the function's even or odd. So we're going to jump in and do a question. So we have a curve here, x squared minus 3x minus 4, and determine its type. We need to find the stationary points and determine its type. Also, using the x and y intercepts, we want to graph the curve. So the first thing to do, remember, is always write down the function again. Find the first derivative. And then we want to find our stationary points. Now remember, stationary points occur when the first derivative equals 0. So we can do that. We can write down that 2x minus 3 equals 0 plus 3 to both sides because we want to solve this. We get 2x equals 3, and then we can divide by 2. And we get x equals 1.5. So we know there's a stationary point at 1.5. So let's find the y value for this. So we'll identify the y value at this point. And we do that by substituting that x value back into the original equation up here. Alright? So if I do that, we get f 1.5 equals 1.5 squared minus 3 times 1.5 and then minus 4. Now if you put that in the calculator, you're going to come out with something like negative 25 over 4, or probably a better way to do this when you're sketching, it's probably better to leave it as a mixed fraction, so minus 6 and 1 over 4. Alright, now that we've got that, we need to determine what's the nature of this. What is it, minimum, is it maximum, what is it? So determine nature. So we need to find our second derivative. Now if we just go back to the first derivative, which was up here, we're just differentiating that. And differentiating that equals 2. So remember, if our second derivative is greater than 0, remember we have a minimum. Right, so we know we have a coordinate here at 1.5 and then negative 6, 1 over 4, and we know it's a minimum turning point. The question also told us to find our intercepts, so let's start by finding our x-intercepts. And that occurs when y is 0. So if we just change our function to 0 equals x squared minus 3x minus 4, we can factorize this down. If you want to use the quadratic, you can, but essentially you'll get x minus 4x plus 1. So we have two x-intercepts. We have an x-intercept at 4 and an x-intercept at minus 1. So remember, that's where it's crossing the x-axis. Now we want to find our y-intercept. And that's when x is 0. And usually this is just the constant, and you'll see y in a second. So if I change all my x's to 0, we have a constant of minus 4, and that happens to be also the y-intercept. So at this point, we've got a lot going on. We should list and make sure we know all the points and coordinates we just found. So we'll say list all coordinates. Otherwise it can get messy and we might miss something. So the first coordinate we found was our stationary point, and that occurred at 1.5 and negative 6 1/4. Now this was a minimum turning point. The next point we found was our x-intercepts, so we know there's at 4 minus 0 and minus 1, 0. These are our x-intercepts. And the last thing we found was our y-intercept, and that occurred at 0 minus 4, and that was our y-intercept. Alright, so knowing that, we can start to sketch some sort of graph. So I know roughly there's a point here at minus 1. We have another point over here at 4. I have a y-intercept at minus 4, let's say down here. And then we also have our point down here. Now this point down here is going to be our 1.5 and our 6.25 or 6 1/4, alright? So remember, it was a minimum, so if we just connect all the lines, that's a terrible graph, but you get the point. And that there is our sketch of the graph. So we'll do one more. So here we have another function. So we're going to do the same thing. Write it out. 2x cubed minus 9x squared minus 24x plus 30. First derivative is going to be 6x squared minus 18x minus 24. We want to find our stationary points. So remember, that occurs when that is 0. So we go 0 equals 6x squared minus 18x minus 24. There's a common factor there. The highest common factor there is 6. So let's divide everything by 6. We get minus 3x minus 4. We can factorize that down to get x minus 4, x plus 1. So there's two stationary points, one at 4 and one at x minus 1. Right? So let's focus on our x equals 4 first. So let's find our y value. So the y value for here is going to be, all we're doing is changing all the x's to 4 in the original function. Chuck that in your calculator and you'll get minus 82. So there's a coordinate at x and then minus 82. We need to determine what its nature is. So let's find the second derivative. And that ends up being 12x minus 18. Now remember, all I'm doing there is differentiating my 6x squared minus 18x minus 24. We substitute in our x equals 4 here, so we get 12 times 4 minus 18, which equals 30. And since this here is greater than 0, we know we have a minimum. Alright, so we focus on the next point now. So I am going through this rather quickly because you notice that it's the same pattern that I did with the first part question. So here we're going to focus on x equals -1. So again, I'm not going to write it all exactly everything I'm doing here. So when we substitute in, we get a y value of 43. When I put it into the second derivative, we get a -30. And since our second derivative here is less than 0, we have a maximum turning point. Alright, the next thing we should find is probably find the y-intercept. That's an easy one, it's not relatively difficult to find. So y-intercept, and remember that's when x equals 0, so it's usually just your constant. So the constant in our original equation, if we go right back up here, is +30, so I know there's my y-intercept is going to be 30. Now that we've got a bunch of coordinates, it's a good idea now to list them all so we don't forget anything. Alright, so we have 4 minus 82, and that was our minimum turning point. We had another turning point at -143, and that was a max. And then finally, we did find the y-intercept, which was 0.30. Alright, so now we can whip up a sketch for this. So I want to start putting values in, so let's say about here, that can be 30. Over here we had something like our -143. And then finally way down here, we had our 4 minus 82. Now, the top one here at -143, that was maximum, so we know it's going to look something like this, and it has to go through there. We had a minimum turning point down here, so it should look something like that. And then we need to join these points. And then we got our sketch there. So there was a lot going on in this video. So to recap, remember, start by finding any stationary points. That's always a good step. And then determining what type of a stationary point they are, whether they're maximum or minimum. You should also try to find out if there's any points of inflection. X-intercepts and y-intercepts are very helpful as well. Y-intercepts are usually the easiest to find. Sometimes you will need to find the domain and range, and any asymptotes, and sometimes you can use symmetry. But for most questions, you will need to find the stationary points first, determine if they're minimum or maximum, and then go from there. Again, there are different patterns, like I said at the start. If it's too difficult to find the second derivative, you can use the first derivative to determine a maximum or minimum turning point. So remember that.